Hello and welcome back to my channel, students. As you all know, we are doing a problem series, and in this problem series we have already covered 20 problems. Currently we are working on a very important topic, general organic chemistry. We have already covered a very important topics from this topic like aromaticity, anti-aromaticity, carbocations, carbene ions, basis, acidity and basicity. So let us try to see what is there for us in question number 21. Now let us try to see this question very importantly. As you can see, there is a compound in front of you, and in this compound I have mentioned 4 nitrogens as A, B, C and D, and you have to put the decreasing order of their basicity, and I have already told you how to check the basicity of nitrogen is directly related to the availability of electrons. You understand? Higher the availability of electrons, more will be its basicity. But we have seen that there are circumstances where because of conjugation, because of resonance delocalization, the electrons goes somewhere else and it is shared between more number of atoms. As this becomes a case, the availability of electron on a single atom decreases, because now the same lone pair is shared between many atoms because of resonance and delocalization. So higher the conjugation, higher the number of resonating structures, more will be the delocalization of that lone pair, and therefore lower will be the availability of the lone pair on a single atom, that is nitrogen. So it will reduce the basicity of nitrogen. That is a very important point in these type of problems. So now let us try to understand the same point of view using this problem. Now I will take up the nitrogens one by one. I will start with nitrogen number A, the first. As you can now see the nitrogen number A, you can easily see that this lone pair which is on nitrogen number A is under conjugation. How? Lone pair, single, double. So as you find that there is a conjugation, it will get delocalized. And how it is going to get delocalized, I have told many times. You have to get these electrons one position ahead to make a new pi bond, and simultaneously these pi electrons are going to sit over this carbon, bringing a lone pair to this carbon along with a minus formal charge. And as the same you can see on the next, in the next resonating structure, the nitrogen will get a positive charge because the electrons are going away from it. A new pi bond is created, and now the lone pair is seen on this carbon with a negative formal charge. It is not an end to the resonance because further conjugation can also be seen. How? That is seen like this: lone pair, single, double, or minus single, double. After looking at this, now you are tempted to go further in conjugation, go further in making the resonating structures. So that is that you can make by floating these lone pair one position ahead to make a new pi bond, and simultaneously these electrons are now going to sit on this particular carbon and bringing a lone pair and a minus formal charge. And the same thing you can see in the next structure I have done. And as now you are looking at this lone pair with suspicion that there may be more resonating structures where the lone pair can be delocalized, and you find that yes, there is again a possibility how the lone pair, single, double. And then after finding this possibility, you have to delocalize the lone pair one position ahead to make a new pi bond, and simultaneously these pi electrons are going to sit over this oxygen, bringing a lone pair, new lone pair on it with a negative formal charge. So as you can see this next resonating structure. After you have drawn all these resonating structures, you come to a conclusion that while you have drawn these structures, the lone pair was not remaining localized on the nitrogen A, and because of conjugation it hopped from one position to another, and it was in this way shared amongst many atoms. And as the number of sharing increases, the availability on a single atom, that is nitrogen, reduces, and it reduces the basicity of the nitrogen. So if you try to count how many atoms are sharing, so 1 atom, 2 atom, 3 atom, and atom number 4. So the same lone pair through resonance got spread and shared amongst 4 atoms. So with a single nitrogen, obviously the availability is going to get reduced. Now let us try to understand about B. Is there any conjugation, and if it is present, how many are going to share that? After you are looking at the lone pair number B, you found that, oh, again you have conjugation. How? Lone pair, single, double, and because of this conjugation, the lone pair will get delocalized. How? This lone pair is going to go like this, and these pi electrons are going to sit on this particular carbon, bringing a minus formal charge and a lone pair. So as you do that, student, this nitrogen will get a plus charge as the electrons are going away from this nitrogen. A new pi bond has been created, and now this carbon, as you can see, is now having a minus charge, a lone pair. Now is not an end to this resonance process, because you have found that again there is a possibility of delocalization, the minus charge or lone pair, single bond, double bond. So you can delocalize it further like this, the lone pair one position ahead, making a new pi bond, and simultaneously these electrons are going to sit over this carbon, bringing a lone pair and a minus formal charge. So you can see that the final structure I have made. So in this course of delocalization, you can simply find that, you can see that the same lone pair is shared amongst 3 atoms. Which are those 3 atoms? This particular nitrogen 1, this particular carbon 2, and this particular carbon 3. So from this delocalization, you can easily see that there is a possibility of resonance. So that is how you have to think about one pi bond is not here, this pi bond is here like this. So you have seen that the same lone pair is delocalized amongst 3 atoms. In a similar manner, in the case A, you saw that the same lone pair was shared amongst 4 atoms. Now in the case B, 4 atoms, 1, 2, 3 and 4. In the case B, you saw that the same lone pair is shared amongst 3 atoms. As you can see, this lone pair, this carbon and this carbon. So as you can see, this one, this 2 and this 3. So 3 atoms are sharing the same lone pair. Now coming on to the nitrogen number C. Once you see that about the nitrogen number C, you find that there is no conjugation. How? Lone pair, single, single, or lone pair, single, single. So as you find that the lone pair is not in conjugation, so there will not be delocalization of these electrons, and if the delocalization is not there, it will remain localized. It will remain localized on that nitrogen. So the availability of the electron pair is going to be higher, and as the availability goes higher, the basicity will also go higher. So the point is, more you delocalize, more you make the resonating structures, lesser will be the availability on single atom, and basicity will be affected, will go down. And as you can see in the case C, there was no conjugation, so there was no question of delocalization through resonance, so it was most available, so basicity will be highest. Now coming on to the case number D. Now once you see the case number D and try to figure out if there is any possibility of delocalization, the conjugation, you find that yes, there is a possibility. How? Lone pair, single, double. As you see this possibility, you again try to delocalize the electron pairs and you do it like this. The lone pair goes like this and these pi electrons sit over this carbon to bring a lone pair and a minus formal charge. So from here I have drawn this structure. You can immediately see that the electrons are going away from this nitrogen. A plus will come. A new pi bond has been created and this carbon will acquire a lone pair and a minus formal charge. And you find that is not an end to the resonance process, because again it is in conjugation. How? Minus, single, double. So after looking at this, you have to delocalize it further, and once you do that, you find new resonating structures are going to form. You have to delocalize it one position ahead to make a new pi bond, and simultaneously these pi electrons are going to sit over this carbon, bringing a minus charge and a lone pair. And as you are now looking at this carbon bearing the lone pair and thinking about if there is more possibility left or not, you find that yes, there is still a possibility left. Minus charge, single bond, double bond. So you have to delocalize it one position ahead, making a new pi bond, and simultaneously these pi bond are going to sit over this oxygen, bringing a lone pair and a minus formal charge. So you can see that this is the final structure. So if you see all these four structures, you believe that the lone pair was not localized and it was delocalized amongst atoms. Now it was delocalized amongst atoms means what? You should understand that, one second, I think, okay. Now as you see that the lone pair was delocalized amongst how many atoms? Let us count how many atoms it was delocalized on. So you count 1 atom, 2 atom, 3 atom, 4 atoms. So it is delocalized over 4 atoms. In the final slide I will make a comparison of all these, how many atoms the lone pair was going towards. Now finally I come to a comparison in this final slide, and you believe that this lone pair on nitrogen number A, when we drew the structures, the resonating structures, we found that this lone pair, because of resonance and conjugation, was spread amongst 4 atoms. This atom, this atom, this atom and oxygen. So there was a complete conjugation in this manner. Again, you found that B was spread amongst 3 atoms. This atom, this atom and this atom. You can revisit the slide to find why I am saying 3 and 4, 3 or 4, because of the resonating structures I drew on those slides. Now, so this lone pair spread over 3 atoms. This lone pair spread over 4 atoms. You found that in the case of C, there was no conjugation. Lone pair, single, single. Lone pair, single, single. So there is no delocalization. So it is a place where electrons are going to remain localized, not going anywhere else. So is going to be most basic in nature because of the highest availability. And in the case of D, again in the previous slide I showed you that there are 4 atoms which are going to share the lone pair. Those are this atom, this atom, this atom and oxygen. You can see the structures I have drawn in the previous slide. Now if you make a comparison, that then you immediately come to a conclusion that C is going to be most basic. There is no doubt, because the electrons are completely localized, are not going anywhere. Now then comes the nitrogen number B, because here the electrons are just shared amongst 3 atoms. So per atom the availability will be higher in comparison to the spread of A and the spread of D, because in both the cases the electron pair, the lone pair, are getting shared amongst 4 atoms. So after C will come the number of B in basicity, in the availability of electrons. Then will come the A and D. Now, how you are going to decide amongst A and D? Because in both cases, A and D, the electrons are getting shared amongst 4 atoms each. So, you have to think critically this point. Now, I have made you see this scenario in this way. You understand, this is the case A, where the lone pair was remaining at this atom, then it will come at this atom, then it will come at this atom, then it will come at oxygen. In the case D, first you can see there is a lone pair on this nitrogen, then it will come because of resonance at this carbon, then again it will come at this carbon, and finally it will come to this oxygen. Both cases 4. So the only difference is, in the case of D, you should understand, this B is interfering. How? This B is giving electron pairs like this. These electrons are sitting on this carbon, and as you do that, you understand, you make this type of a structure. I will make the structure to make you understand the things. It will become like this. A plus charge will come and a minus will come here. Now what will happen? These electrons are going to use these pi electron. So as these, because this is conjugation, this is minus single double. So these electrons are going to do like this, go like this, and these electrons are going to sit like this. So this nitrogen is basically feeding the electrons towards this nitrogen. Again, you listen what I am trying to say. Both the cases you see, the lone pairs are going away from the nitrogen. Both the cases. But in the case of D, from somewhere else, that is the position number B, the electrons are coming towards the D. So you understand, towards D a negative charge will come and it will bring more electron density towards the nitrogen number D. Because in comparison, if you compare the A and D, no one is giving A. The electrons are simply going away from A. No one is giving. But if you see the D case, it is going, we agree, but it is coming from somewhere also. That somewhere is B. And as you see that, you find that the availability of electrons in the case of D is going to get increased. So this is how you have to think, that both A and D are giving the electrons and it is getting spread over 4 atoms. However, in the case of D, you have a respite that from somewhere else the electrons are coming towards D. And as you make the resonating structures, you believe that electrons are going to come at this position, and that you can see in this particular slide, the slide number B. Can you see that the electrons have came from B and they are hovering over this place, the negative charge. So you understand, the negative charge comes here and these electrons are now going to push the electrons towards the nitrogen, and therefore the lone pair availability is going to get increased. This is the way you have to think, that the availability in the D is going to be more in comparison to availability in A. One more thing you can think about is the pi bond. You understand, this pi bond is used by both D and B. D is using it to give and B is using it to give D. I mean, from D the electrons are going away from the same pi bond, and from B the electrons are coming towards the D from the same pi bond. So that opposite effect neutralizes some giving ability of the D. So on D the availability is increasing, and that is how you have to think, and therefore the final tally comes as the C, then comes the B, and then comes the D, and finally the least one is going to be the A. So this is the final tally based on the availability of electrons. How critically you have to think, and especially in the case of breaking the ice between A and D, how in A and D both cases the number of atoms sharing the lone pair remained same, but the D got electrons from somewhere else also, so it compensated its giving ability a bit, and therefore the availability increases. And that is how we have dealt in this problem. And similar type of problems I will try to bring in future also. Till then, keep a good watch on my previous videos. And I also urge you all that if you find any difficulty, if any problem comes in your mind, you should ask in the comment section, and I will definitely going to clarify your doubts there. Okay, till then, take a good care of your health and happiness. Thank you very much.